Hi everyone, this is Mr. Richmond, and for this video I'm going to walk you through how to calculate total resistance in both a series and parallel circuit. So before we get started on crunching the numbers, I want you to be able to make sure that you can identify what symbol is a resistor, which is represented by this little zigzag here, and what symbol is voltage, which are these two small dashes, and then the lines that we see are just the current. So that's important to know before we start looking at how to calculate the total resistance. So to calculate for total resistance in a series circuit, and we know that this is a series because there is one continuous pathway for electrons to flow, all you have to do is follow this formula up here, and you are just adding the resistor amounts for each resistor, R1, R2, R3, R4, if there's 4, R5, and so on if there's 5 resistors. So I see 1, 2, 3 resistors for number 1B, and this is as easy as adding up these three. So 2 plus 2 plus 2 is 6. So my answer for B would be 6 ohms. Let's see if I can get my brush. So 6 ohms. And then from here I have resistance. For my next problem here, I've got voltage in my symbol, which is 9. I just solved for resistance. So by using Ohm's law, we should be able to solve for current as well using V equals I times R. Same thing for power, because you solved for current right here. You have current, you have voltage from the symbol, you should be able to solve for power. So keep that in mind, as you cannot do each one of these questions without doing the one prior. So start off with number 1 and work your way down. In calculating total resistance in parallel circuits is a little bit more of a challenge. We've got this formula to deal with. It's not as easy as just adding up all of these resistors, so please keep that in mind. So let's look at this formula, and what I want you to do, the first thing that you see, or the first thing that you do when you see this formula, is to rearrange this algebraically. And if I were to have my total resistance to be equal to, I'm going to put the numerator, I'm just going to kind of bring this numerator of 1 over here, and then I'm going to put that over the sum of 1 over R1 plus 1 over R2 plus 1 over R3 and R4 if it's applicable. So I'm going to do number 4B, which is on the second page of this document that you're working on, because it's a little bit more complicated. We need to find the common denominator, which we do not need to do over here for A because it's already similar. So when we're adding fractions, we want to make sure that we have our denominators in line with one another. So if I were to add my resistance, which is 3 for R1 and 6 for R2, I'm going to go ahead and make sure that I plug in my resistance for 3 into R1, my resistance of 6 into R2. And if I were to look at that in terms of their fractions, I want to make sure that I have my denominators matched up, which they're not, so I cannot add this as is. It's not really going to quite equal out, so I want my lowest common denominator to both be 6. 3 times 2 is 6, so I need to double my numerator as well. So now I'm going to add my numerators. I can do that. 2 plus 1 is 3. Keep your denominator the same, so that's the equivalent. The sum of 2 over 6 plus 1 over 6 is 3 over 6, or 0.5. If you want to convert that into a decimal, that's fine. I'm not done, however, so all I did is I took the sum from my denominator over here, and that sum is 3 over 6, or 0.5. I'm not done. I need to divide that by the numerator. So 1 divided by 3 over 6, or in other words, 1 divided by 0.5 is 2. So my total resistance in this parallel circuit is 2 ohms. And you're going to go through the same process that you did for the series circuit. You're going to need to calculate for current using Ohm's law. So now that you have your resistance, you have the voltage, you can solve for current. Once you solve for current, you can then solve for power because you have current and voltage. So I hope this video was helpful for you, and good luck with the rest of your assignment.